Hello, you are welcome. The question here says a particle of mass 50 gram performs simple harmonic motion of amplitude 10 cm and period 4 pi seconds. When it is at a distance of 8 centimeter from the equilibrium position, calculate A, its potential energy, and B, its kinetic energy. And we are given pi as 3.142. Now, for us to solve this, I'll first of all like us to take down what we are given in the question. So if you look at it, let me write solution. And then with question A, I would like to write what we are given. Now, we are given the mass as 50 gram, but in physics, we do not use gram as SI unit, we use kilogram. So it's going to be 50 divided by, to convert gram to kilogram, we divide by 1000. And that will give us the value of the mass as 0.05 kilogram. Then what else are we given in the question? We are also given the amplitude, 10 centimeter. So amplitude is letter A and is equal to 10 centimeter. But in physics as well, we do not use centimeter as SI unit, rather we use meter. So to convert from centimeter to meter, we simply divide both sides. We simply divide the value by 100. And that will give us 0.1 meter. So that is the amplitude. What else are we given in the question? We are given the period T. The period is capital letter T, and that is given to us as 4 pi seconds. 4 pi seconds as the period. And then we are also given the distance from the equilibrium position. That's its distance, which is 8 centimeter from the equilibrium position. Equilibrium position also means the center of the motion. So that distance from the center of the motion or from the equilibrium position is given letter S and is equal to 8 centimeter from the question. So for us to convert centimeter to meter, we divide by 100 and that will give us 0.08 meter. Now that we have listed the parameters that we need, we can now go ahead and apply the formula for potential energy. But before we apply that formula, it is very important that we calculate the angular velocity. So the angular velocity, which is represented as omega. So angular velocity is given by 2 pi all over the period. Don't forget this formula for angular velocity. And that will be equal to the 2 pi. Since we are given period in pi, then we can leave the pi like this. There is no need of using 3.142 given to us in the question. So we can use the value of pi like that because pi will later disappear. So the period is 4 pi. So you can now see that pi will cancel pi and we are left with 2 over 4. 2 over 4 is equal to 0.5. And the unit of angular velocity is radians, which is rad, per seconds. Per seconds. So that's the unit of angular velocity, radians per seconds. Now that we have obtained the angular velocity, we can now go ahead and calculate the potential energy, which is the first question that we are asked. Don't forget, the first question there says we should calculate the potential energy. So now, let me put down the formula for potential energy in terms of angular velocity. So that formula is potential energy is equal to half multiplied by the mass multiplied by the angular velocity square and then multiply by x squared. Take note of this formula for potential energy of a body in simple harmonic motion. So from there, we can now apply the value, substitute in the value. So I have 1 over 2 multiplied by the mass as given to us. You can see the mass is 0.05 kilogram. So 0.05 and then multiply by omega, that is the angular velocity, omega is 0.5 that we just calculated now. So 0.5 square, the omega has to be squared, and then multiply by the value of x. You can see the value of x there as 0.08 meter. So 0.08, and then we also square it. Don't forget, it has to be square as well. And then we can now use our calculator to carry out this calculation. You square this, multiply by the square of this, multiply by this, and then finally you divide by 2. It's going to give you the potential energy, PE, as 4 times 10 raised to the power minus 5 joules. The formula for energy is joules. So this is the potential energy. Hope you are getting it. Please don't forget to like, share, and subscribe to this channel as you are watching. Then let's go to the next question. The question B, the B part says that we should calculate the kinetic energy. Don't forget the second question there. It says that we should calculate its kinetic energy. So now, in terms of angular velocity, we can also get a formula to calculate the kinetic energy of a body in simple harmonic motion. And I'll give you that formula. It is Ke is equal to half m, then you square the omega, omega square, and then bracket open the amplitude square minus x square. So this is the formula to calculate the kinetic energy in terms of the angular velocity omega and then the mass. Then now we can substitute values so that we get that kinetic energy. So I say half multiplied by the mass is 0.05 multiplied by the angular velocity is 0.5. Let's not forget that value. In case you have forgotten, let me show you here. This is the angular velocity, 0.5 radians per second. So angular velocity is 0.5. So I'm going to write it as 0.5 and then, that is multiplied by 0.5. Multiply by 0.5. Sorry for that. So this is the mass, then multiply by the angular velocity square. We have to square the angular velocity. Take note of that. And then we now multiply by the amplitude. Let's go and check the amplitude so that we can see those values. You can see the amplitude from the beginning. The amplitude A is 0.1. Hope you are seeing it. The amplitude is 0.1 and the value of x is 0.08. So we're going to substitute these values now into this equation. So I have amplitude 0.1 square, then minus the x, which is 0.08 square. So these are the values that we need to substitute. So that will be equal to, so by the time you square this, please take note of how to use calculator correctly. You square this minus the value of this squared, then multiply by 0.5, which is the omega square, and then you multiply by 0.05, and then finally you can divide by 2. By the time you do that, you are going to get the kinetic energy, Ke, as equal to 2.25 times 10 raised to power minus 5 joules as the answer for the kinetic energy. And that's the final answer. Hope you enjoyed this video. Please don't forget to like, share, and join for more videos like this. Thank you for watching.